Bill Nye once distilled a profound truth. Your skin is where you create life-giving vitamin D, but the very sunlight that enables this can also erase your ability to create life at all. This single conflict is the engine behind one of the most powerful adaptations in human history, the color of your skin. It is not a random detail, but a precise biological solution. Understanding this science will reshape how you see yourself, your ancestors, and the very map of humanity. We have been conditioned to see this through a social lens. The reality is far older, written into your DNA as a survival story spanning 200,000 years. To decipher that story, we must first go back to the beginning. Back to the single, fundamental dilemma evolution was forced to solve, an ancient, high-stakes negotiation with the sun itself. That negotiation revolves around two non-negotiable and contradictory biological demands. Both are governed by the same force, the sun's ultraviolet radiation. On one side of the evolutionary scale, UV radiation is a silent saboteur. It systematically destroys folate, a critical B vitamin circulating in your blood. Without enough folate, the most fundamental process of life, DNA synthesis and repair, begins to fail. For our ancestors, the consequences were devastating to the survival of the group. It meant failed sperm production and catastrophic birth defects like spina bifida. A landmark study in 2000 put a number on this invisible threat. Just 1 hour of intense sun can destroy up to 50% of the folate in your system. But on the other side of that same scale, you are biologically dependent on that very same radiation. Your skin is a sophisticated factory designed to synthesize vitamin D, and UV light is the essential trigger. Without it, your skeleton cannot properly absorb calcium, leading to the debilitating bone disease rickets. Your immune system, your primary defense against pathogens, is also critically weakened. This is the core dilemma, the high-stakes trade-off at the heart of our evolution. The same energy from the sun that builds a strong body also carries the power to compromise the creation of the next generation. To protect folate, you need a shield. To produce vitamin D, you need an opening. Every shade of human skin is simply evolution's finely tuned answer to this singular problem. This single evolutionary conflict shaped all of us. Which side of this trade-off do you think your own ancestry leaned towards? Let me know in the comments below. And if you're intrigued by these kinds of deep dives, consider subscribing. With the battle lines so clearly drawn, evolution's first solution had to be decisive and uncompromising. To understand it, we must go to where the UV radiation is most intense and where our human story began, the equator. Here at the equator, where our story begins, the sun is not a gentle visitor. It is a constant vertical force, year-round. In the face of this relentless radiation, evolution's first answer had to be decisive and uncompromising. That answer was deep, ebony skin. Think of it less as a color and more as a living, biological shield. Its primary mission was not to prevent sunburn, which is a trivial risk in the grand scheme of survival. Its purpose was to guard something far more fundamental to the continuation of our species: folate. This crucial nutrient, essential for healthy reproduction and development, is rapidly destroyed by UV radiation. So, evolution developed this shield. Packed with a high concentration of U-melanin, it blocks up to 95% of incoming UV rays, effectively creating a protective sanctuary for folate within the body. In an environment so saturated with sunlight, the small percentage of UV that still penetrates is more than enough to synthesize the necessary vitamin D. The system was in perfect, resilient balance. This was the original human blueprint, a flawless adaptation for a specific world. But this perfect shield carried a hidden vulnerability. It was calibrated for only one place on Earth. The moment our ancestors took their first steps out of the equatorial cradle, this profound strength became a life-threatening liability. To leave was to challenge the equilibrium, forcing evolution to find a compromise. And that compromise began not as a radical reinvention, but as a subtle recalibration. As human groups migrated away from the intense direct sun of the equatorial belt into places like West Africa, South Asia, or Melanesia, the evolutionary equation changed. The perfect shield, designed for maximum UV blockage, was now a potential liability, threatening to block the synthesis of crucial vitamin D. The first adjustment was a slight turn of the biological dial. This resulted in rich, dark brown skin. It still offered formidable protection, but by allowing about 20% more UV penetration, it opened a small, vital window for vitamin D production. This was the first concession in the high-stakes negotiation between folate protection and vitamin synthesis. In other tropical and subtropical zones with more variable sunlight, a more complex solution emerged: mahogany brown skin. Here, the adaptation is even more precise. Blocking around 70 to 80% of UV radiation, this phenotype often indicates a sophisticated mix of pigments, not just the dark eumelanin, but also reddish pheomelanin. It's a finely tuned filter, calibrated for an environment where the sun is still powerful, but not a constant year-round assault. Beyond these fixed adaptations, evolution also engineered a dynamic, real-time solution. You know it as the ability to tan. This is not a cosmetic change, it's a primal defense mechanism. Your body recognizes the cellular damage from UV exposure as an attack. In response, your genes signal your melanocytes to ramp up production, deploying a temporary, stronger shield of melanin to protect your DNA and folate reserves. It is an on-demand armor, a biological intelligence that adjusts your defenses to meet the immediate threat. But what happens when you move from a world of consistent sun into one defined by seasons? A world of long, dark winters followed by bright summers. Evolution needed a more dynamic, more intelligent solution, a sweet spot written into our genetic code. That sweet spot is found in the third major adaptation, the seasonal specialist. As our ancestors moved into regions with distinct seasons, like the Mediterranean basin or parts of South Asia, evolution engineered a new phenotype, light golden brown skin. This is the biological sweet spot, a near-perfect balance between protection and production. This phenotype possesses a remarkable ability to adjust its melanin production on the fly. It's a system designed to tan quickly in the high UV summer, building a protective shield when needed, and then lighten during the low UV winter to maximize vitamin D synthesis. It is not a static color. It's a year-round efficiency engine written into your biology. A close cousin to this strategy, often found at the ancient crossroads of human migration like southern Europe in the Middle East, is the olive tone. This is a genetically diverse compromise, but it holds a fascinating secret. Some scientists refer to it as a form of optical camouflage. Its neutral undertones can cause the skin to appear functionally darker in bright, direct sunlight, enhancing protection, yet lighter in the shade, aiding absorption. It's a subtle but brilliant optimization that works across a spectrum of daily lighting conditions, contributing to the stable vitamin D levels often observed in these populations. This dynamic, seasonal balance is an elegant solution, a testament to evolution's fine-tuning. It works perfectly until it doesn't. As our ancestors continued their journey, pushing further and further north, they walked straight into a new kind of biological crisis. The enemy was no longer the sun. For the first time, it was the sun's absence. This absence wasn't a matter of comfort. It was a matter of chemistry. As our ancestors pushed into the high latitudes of what we now call Central and Northern Europe, the problem inverted entirely. For the first time, evolution was fighting not an overabundance of sun, but a devastating lack of it. This triggered a new survival threat, vitamin D deficiency. In a world shrouded in gray, overcast skies, this wasn't a minor inconvenience. It was a silent epidemic. It meant rickets, a cruel disease that left bones too soft to support the body.
It meant weakened immune systems and staggering child mortality. The skeletal remains from medieval Europe tell this grim story in silent detail. A population struggling against an invisible enemy, their very bones betraying them.
The first response was a dramatic reduction in melanin, creating what we might call a warm beige skin tone. This adaptation significantly increased the skin's ability to absorb the weak UV radiation, while retaining a strong capacity to tan as a defense for the rare but intense summer sun. But for those who went even further north, this wasn't enough. Evolution made a more radical choice: fair, light skin. By dropping melanin to minimal levels, the skin allowed approximately 5 times more UV penetration. This wasn't a minor tweak. It was the difference between life and death in a place where sunlight was a fleeting resource. The notorious vulnerability to sunburn wasn't a design flaw. It was an acceptable risk, a calculated sacrifice in a world where the alternative was a generation of children unable to stand tall. This radical solution, sacrificing protection for production, seems like the final, desperate chapter of the journey. But it's not. Ancient DNA reveals that the most shocking part of this adaptation wasn't what it was, but when it happened. The answer to that when takes us to the final stop on our journey, the absolute extreme of depigmentation. This is the very fair skin found in places like Ireland and Scandinavia, a response to environments where ultraviolet radiation becomes critically scarce, especially in the long, dark winters. Here, the evolutionary equation is solved with a stark simplicity: maximize vitamin D production at all costs. And this is where ancient DNA delivers its most staggering revelation. If you were to visualize the 200,000-year timeline of our species, this adaptation doesn't appear somewhere in the middle. It's not a slow, steady drift. Instead, it's a frantic explosion of change crammed into just the last 5,000 to 10,000 years, a tiny sliver at the very end of our history. This wasn't a gentle process. It was intense, rapid natural selection. In these northern latitudes, individuals with even slightly lighter skin had a dramatic survival advantage. They were more likely to stay healthy, avoid crippling bone diseases, and successfully raise children. Evolution wasn't just suggesting a change, it was enforcing it, generation by generation, at a speed rarely seen in the human story. We have now traced the entire spectrum of this survival story, from a biological shield to a solar panel. It paints a map of profound, hard-won difference. And yet, the final, unifying twist in this journey reveals that beneath it all, at the most fundamental level of our biology, we are all the same. This sameness isn't found in the reflection in the mirror. It's in the fundamental biological machinery you cannot see. Here is the first and perhaps most profound twist. Every single human, regardless of skin color, has virtually the same number of melanocytes, the tiny factories that produce melanin. The difference is not in the hardware itself, but in the software that runs it, the genetic instructions that dictate the activity level of those factories and how they distribute their product. Pause here for a moment. The idea that we all share identical biological hardware is powerful, but if you believe that is the main point, you're missing the true elegance of the design. The real story isn't the hardware, it's the software. And that software evolved at a speed that will challenge everything you think you know about evolution. This brings us to the second twist. Your skin color is one of the fastest evolving traits in the entire human genome. The dramatic depigmentation in Northern Europe, as we saw, happened in as little as 5,000 years. This isn't the slow, grinding pace of textbook evolution. This is a rapid, high-stakes adaptation, almost like a software update pushed out to an entire population under extreme pressure. And evolution's genius didn't stop at the surface. The third twist is that this rewiring went deeper. In some populations, evolution also fine-tuned the internal systems. It enhanced the body's sensitivity to the vitamin D it produced, or it developed more efficient proteins to transport that vitamin through the bloodstream. It was a full-stack biological solution. So you see, evolution didn't just paint us different colors, it rewired our entire relationship with sunlight at a molecular level. This isn't just a story about genes and sunlight, it's a story about you. Because understanding this code doesn't just change how you see the world, it changes how you see yourself. Your perception shifts. What was a superficial label judged by fleeting social standards becomes something else entirely, the living record of your ancestors' journey. The sun they faced, the climates they endured, and the precise genetic resilience that led directly to you. This understanding is the internal compass. It confirms your biology is not an oddity to be questioned. It is a profound inheritance of survival. So look again, because every single shade tells a story of human adaptation, written in the ink of melanin and genetics. A story 200,000 years in the making.
If this journey into our shared past has changed how you see your present, subscribe for more deep dives that connect science to the human story. Thank you for watching.